Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Parity Penpalindromes by Signe. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have digits along a red parity palindrome line read the same forward and backward and alternate between odd and even digits. So, for example, you could have something like, say, 5, 4, 7, 2, 7, 4, 5. And this would be valid because it reads the same forward and backwards, and it alternates between odd and even digits. Right? So it reads 5, 4, 7, 2, 7, 4, 5, 5, 4, 7, 2, 7, 4, 5. And that's an example of how the parity palindrome line works. We have any set of 3 adjacent digits along a peach entropy line must contain one small number from 1, 2, or 3, one medium number from 4, 5, or 6, and one large number, which is 7, 8, 9. So, for example, you could have something like, say, 3, 5, actually, let's do 3, 8. 3, 8, 5, 1, 7. And this would be valid because for any 3 digits along this peach entropy line, you have one digit from a low digit, 1, 2, and 3, one digit from a medium digit, 4, 5, and 6, and one digit from a high digit, which is 7, 8, 9. So here you have 1, 5, and 7. 1 is low, 5 is medium, 7 is high. You also have 1 is low, 5 is medium, 8 is high here. And 3 is low, 5 is medium, and 8 is high here. So that's how the entropy lines work. We have digits separated by a V add up to 5, and digits separated by an X add up to 10. So, for example, if you had a 3 here, you would have to have a 2 here. If you had a 3 here, you would have to have a 7 here, because these two digits must add up to 5, because there's a V between them, and these two digits must add up to 10, because there's an X in between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first things first. Let's start coloring this entropy line. We're going to make them yellow and orange. So, yeah, and we know it alternates parity. So, yellow, orange, yellow, orange. So, these are all, every other digit is yellow. Interesting. Huh. These are all yellow, which means these have to be all, that's not right. No, that is right. So these are all orange, right? Yellow, yellow, orange, yellow. Orange, yellow. Oh, this is orange. Yellow, orange, 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 yellow. So, we have in this upper box 3, we have 4 yellows and 4 oranges. We know there are 5 odd digits in every in every set of 9 unique digits in Sudoku. So this must be red. We have 4 yellows here. We have 4 yellows here. This orange and orange. So the same parities must add up to 10, right? Because if you have orange and if you have 1, you must add up with 9 to add up to 10. If you have 3, you must add up with 7 to add up to 10. Or if you have 2, you add 10 with 8. 4 and 6 add up to 10. So these are the same parity. For here, we're going to have to alternate between, well, let's do dark and medium. So this is dark, medium, dark, medium, dark, medium, and dark. Okay. Let's see. These must be adding up to 1, 4, and 2, 3. To add up to 5. Okay, let's mark these as letters to differentiate them. A, B, B, C, C, C. These are D, E, F, G, H, I, J, K, L, M, N, O, P, Q, and these are R. So this will be S, T, and these are U. Okay. We know A through H are all different digits. We know D, F, R, Q, O, K, I, and H are also all different digits. A cannot be the same as O or K, so A has to be Q or I. It cannot be I, so A has to be the same as Q, right? A sees O and K this way, and it sees I this way. So in column 7, cannot be the red, cannot be O, K, or I, so it must be Q. So Q is the same as A. Okay. We have C, E, and G. C, E, and G are the same as these 3. Okay, so that means C, E, and G cannot be red. C cannot be K or M, obviously. B, okay, so B and H must be the same as H and R. So this cannot, R must be B. Okay. Because it cannot be the red, and then it must be the remaining oranges in this column. So we know C, E, and G is the same as O, K, and I because it can't be red. C cannot be K, so C could be O or I. O, K, and I. E and G cannot be M, obviously. Neither can C. A cannot be here. A cannot be here. Where's A in column 8? A must be the same as M. So M is A also. So we know A is here. A is here. So these are all the A's. Where is A in the middle box? Cannot be here, cannot be here because of A's in the columns. Can't be here, here because A's in the, sorry, A's in the row. Cannot be here, here because A's in the column. So A has to be here. So that means this is yellow. Yellow must be with orange to add up to be adding up to 5 because 5 is an odd digit. You have to have one odd and one even to add up to 5. This digit cannot be, it's A. Okay. O is here and here. Okay. So we got a decent amount of A's. A is one of these two. A is one of these two. What about B? B is either N or this digit here. That seems fine. So B can be one of these two. C. C cannot be here, cannot be here. It's either, again, it has to be either I or it's O. Okay. That's not helpful. D. D cannot be here, cannot be here. That's not too helpful. E. E can't be here or here. It could be KI or an O. F. F cannot be here or here. So F is the same set as D. G. G cannot be here. G cannot be here. Again, it could be K. Oh. I think, okay, so C cannot be here, and C could be one of these three. Interesting. No, that's not helpful. E and I are the same. E and I have to both be these three. H. H is not here, is not here. So H must be one of these three. Oh, A can be over here too. So this is both the same set. This is one of each. Okay. I has to be one of C, E, or G. We already knew that. J cannot be here, cannot be here. So it has to be one of these three. Can it be H? It cannot be H. So J cannot be H. It has to be one of these two. So J is one of these two. Oh, B is one of these two. J is one of these two. So this must be a BJ pair, right? Oh, B cannot be N. There we go. So B and N see each other here. So B cannot be one of these. This is H, so it can't be there. So this is B. So this is not J. This is guaranteed to be B. This can't be B. J again cannot be here. Cannot be the same as H. So it can't be here. Can't be the same as B. Wait, it could be the same as B. J could be the same as B. So then J is one of these two. No, J cannot be the same as B, sorry. Because B and J say each other there. J and H see each other there, so J cannot be either of these, J can't be any of these, so J is the same as N. So this is J. So we have J here, J here. J here, J is one of these three. Cannot be D or F, so J has to be this one. Okay, well there you go. So we know oranges are red, right? J cannot be the same as D and F because of this. So B is, where is B? B cannot be the same as N because of this combination here. So it cannot be there. Cannot be H because of these cells. So this must be B here. Therefore, J cannot be any of these cells. Can't be H or B, so it can't be any of these. So this must be J, which means that's J. Well, J's here, J's here. It cannot be the same as D and F because of these cells here. So J has to be here, which means oranges are odd digits. And yellows are even. So we have 4 evens then in column 6, which eliminates evens in the rest of the column. So darks must be odd, and light mediums must be even. Okay, so then this must be C, E, and G. So that means E and G are here. So we have B, H, J, D, J, and F. This can't be, T has to be, this cannot be G, C, or A. So T has to be E. So T, because we have all, so there are only 4 even digits, so they have to be distinct. So E is here, which means E is here, E is here. E must be one of these two. So E is one of these two. E has to be one out of OK or I. So E and G both see this. That's not helpful. We have J, L, J already. These are 3 odd digits here, because we have 4 even digits in the column. This is odd also. One of these is even, one of these is odd. We don't know which. This is then E or G. Cannot be C. So E or G. Which one is that? That's K? Yeah. E or G. This is E or G. What else do we have? We have A, B, D. So D, H, and F are here. So P is here, P is here. L cannot be B or H, obviously. It's D or F. So this is D or F. Cannot be F because of F in J. Oh, sorry, this is L. Huh. This is D or F. This is D or F. D or F, yeah, where's D and F in box 9? Can't be here. And these are even. Can't be J, B, or H because J, B, and H are in the same box as it. So this must be a DF pair, which means this is blue. So this is red. We have blue here. We have D or F. This is D or F. So this cannot be... Okay, well, it could be the other one. The other D or F. F cannot be here. So this must be D or J for the P. Cannot be J. So P cannot be D. Cannot be F. Cannot be B or J. Oh, wait, we already knew J. This is D, F, or H. Right. Cannot be F. So this is D or H here. So P is D or H. J is J, obviously. So this is D, F, or H here. We have B, F, or H here, so this is D or J. So this is D or J, and this is... Okay, cannot be D. So U has to be the same as J. Right? Because we tried to have... this cell is the same as this. It cannot be B, F, or H, so it's J or D. And it cannot be D. So this has... U has to be J. So U is J. So J cannot be here. J can't be here. So J has to be one of these two. Because J cannot be here, or here, because of J's in the column and rows. J cannot be here, or here, so J has to be one of these two. Okay. We are missing a C in row 3. We're missing a D in row 3. So this is a CD pair in row 3. S cannot be J or B. So it's D, F, or H. So this is D, F, or H. Oh, we have 5 reds in row 4. So this has to be a blue. And J has to be red, so this cannot be J here, which means this is J. So J cannot be here, which means J has to be here, so this can't be A. This is A here, which eliminates A here. So this is A here. And that's blue. This is J as a red. And it must be with red here. Right? Because we have 5 reds in row 4. So the last one's blue. Which means J can't be here. J's there. This is J. We have... This is blue. And it must be C. Because it cannot be A, E, or G. We have all the blues in box 8, so these are not blue, these are red. This is F, J, D. We're missing B or H here, so this is B or H. This is J. So B and H add up to 10. J adds up to 10 with either D or F, and it cannot be D, so this has to be F here, which means this can't be F, this is D, which means this can't be D, so L is the same as F. So these are Fs. So that means D must be a 5. So D is 5. J and A add up to 10, or 5. So F is 6 through 9. So this is B, it cannot be B. So one of these is B and one of these is H. Or one of these could be B, or one of these has to be a B or an H. Actually, that's not true. J can't be here. So this is the other one. Interesting. Okay. So this is B or H. F cannot be here. J can't be here. We have 5 is one of these digits. We have B, F, J all in column 6. So that leaves what? 5 and H as the remaining digit. 5 can't be here, so this must be H, which means S has to be a 5. So S is a 5. So this is H, B, and J. We're missing F. So D cannot be here because it's not 5. So this must be C, which is blue. And this must be 5. So this is a 5. This is C. We are missing G then. So this is a CE pair here in column 6. So O is C or E. And I sees both of these cells. O is here, so these have to be different. And it sees both C and E. So I must be G. So I is G, which means K cannot be G. K is E. And therefore, since O can't be E, O must be C. So this can't be C, it's E. That means this is C here. A, E, and C. G has to be one of these two. This is A, E, G, so this is C. And these are both even. So you cannot have 2 or 8 be on this entropy line. Or no, wait. It's low. One's low and one's high. It has to be 2 and 8. And A has to be the low. It can't be 4 because then this entropy line doesn't work here. So A has to be 2. So A is 2, which means J is 3. F must be 7. So F is 7, and C has to be 8 to be a large digit. So C is 8. And we have 8 8s now. We are missing an 8. We know where it has to be. It has to be here. Because we have 8 8s. So this is 8. That means cannot be a 2 3 pair here. This is 1 4. P is either D or H. It could be 5. It cannot be 5. So then P is H. So H is here. H is here. So we need one out of B or H. That means if B is here, this is B. So H is here. We are missing B and 7. No, B is here. So H is here, B is here. This is a 5-7 pair. This cannot be 5 because of 5 in the row. So this has to be 7, which makes this 5. That means B and H are 1 and 9. Okay. 5 is one of these. So H is here, H is here. Where is the H in row 2? Cannot be here because of H is in the row. Sorry, in the box. So H has to be here. What about B? B cannot be here, cannot be here. It's one of these 2. It's one of these 3. Okay, here we have an entropy set. We're missing a 2. So we're missing a low. So it has to be 1 and 9 here, and we're missing a high. We have 7 and 8, 2, 3, so this must be 1, 9, which means this is 4 or 6 here. So B and H have to be on this line. We need, this is high, so it's 7 or 9. So this is guaranteed 7 or 9, so this is red. And this must be 4 or 6, so this is even. Well, that's even. This is even because of the digits that can remain. So therefore, we have 4 evens in row 8. We have 4 evens in box 1. This must be odd, and this must be odd. So this has to be G. Right, this is a G. This is not E, so it has to be G also. This is E and G here. We have 1, 2, 3, 4 evens in column 3, which eliminates evens in the rest of the column. So this is odd, which makes this even. And this is G. So this must be 1 here, and it cannot be B. So H, this must be H. So all the H's are 1. All the H's are 1. All the G's are 4. And therefore the E's must be 6. And we do the rest just by normal Sudoku. B has to be 9. I guess this is not normal Sudoku, but B is 9. And then the rest we do through normal Sudoku. So this cannot be 9. This is 7, which makes this 9. 9 cannot be here. Where's 9 in column 2? Or 9 in box 7. It has to be here. Therefore, this is not 9. This is not 9. We have 1 and 6, but this is odd, so this is 1, which makes this a 6, and this is a 1. This becomes a 5-9 pair. We have all 9 ones. We have all 9 twos. 3s, we have all 9. 4s, we're missing some. In box 2, 4 can't be here, so 4 must be here. And we have 8 4s now. We know where the last 4 has to be. It has to be there. 5s, we have 1, 2. We are missing 2 5s. 5 can't be here in the middle box, so it must be here, which makes that a 5. 6s, we're missing some. We're missing 1. So we know where the last 6 has to be. It has to be there. 7s, we have 8. No, we're missing 2. 7 in box 2 has to be there, and then the last 7 has to be there. 8s, we should have 8, or we should have 9, and then the last digit is 9. And that's a solution. Yeah, fairly straightforward. Using letters definitely seems to help with these long Penpalindromes. It's just really hard to be able to see things with just colors. So being able to identify what cells can be which letter is very helpful, right? And you have a lot more letters than you have colors, so it's easier to track that down that way. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.